Throughout the previous course, we looked at everything we needed to correctly model a given reality in Genexus. In this video, through the analysis of a limited reality, different options are analyzed to design transactions using a set of essential resources and solving a series of real requirements. Let's suppose that a Genexus application needs to be designed for managing the tasks of a library related to the loans of books, magazines, and notebooks. It works with members who can access different reading materials, such as books and magazines, as well as computer equipment loaned by the library. The information to be recorded is as follows. Country. Each country is registered with a unique identifier and its name. Member. Each library member is registered with his or her ID card, name, address, photo, and a contact phone number. Library members must be 20 years of age or older. Author. Each author is registered with a unique identifier, name, photo, and country of origin. An author can have several books published. Book. Each book is registered with a unique identifier, title, date of publication, and number of copies available in the library. It can be a novel, an essay, a poetry book, and so on. Therefore, a book belongs to a literary genre. In addition, a book has an author and a publishing house in charge of its publication. Magazine. Each magazine is registered with a unique identifier, title, date of publication, cover image, and the number of copies available. Notebook. The library's services include loans of notebooks to its members, since many of them are writers and researchers. Each notebook is registered with a unique identifier, its image, and a short description. In addition, its status, available or checked out, is recorded. Loan. The library loans books, magazines, and notebooks to its members. Each loan is recorded with a unique identifier, the date of checkout, member, and due date, which must be automatically determined. All loans are for 15 days. They may include a maximum of 3 books, 4 magazines, and may or may not include the loan of a notebook. Only 1 copy of each publication may be checked out, and it's possible to enter any comments considered necessary at the level of each copy's loan. In other words, a damaged cover, missing pages, and so on. In addition, the date on which a new loan is recorded is always the current date, and it must not be possible to change it. Request for copies, book request. It often happens that certain books are in high demand, and the library decides to request more copies. To this end, it makes a request to the corresponding publishing house. The system must check that book copies are requested from the indicated publishing house. Let's start to analyze this reality. Initially, we can clearly distinguish certain simple entities that we can begin to define, such as, for example, country, member, and author. But first, we should take into account that most of the entities are registered with an identifier that can be auto-numbered, except for the member number, who, as we mentioned before, is registered with his or her identity document. Therefore, we define the domain ID with the auto-number property set to true. We also define the name domain as a character of 20. Let's start by defining the country transaction, with country ID as primary key and country name as a secondary attribute. Country ID is based on the ID domain, and to check that the name is not repeated, we define the corresponding unique index. This same definition is valid for all entities where it's necessary to check that the name is not repeated. If it were necessary to record the cities of each country, because we need to know the city of birth of the author, we could model it as a weak entity in relation to the country, since a city does not exist outside that context. So a second level would be added to the country transaction, but since city is considered a weak entity, it will not exist as a transaction in itself. This means that city ID will not exist as a primary key in any table, and therefore, in order to know, for example, the city of birth of an author, the pair made up of the attributes country ID, city ID, which will be the primary key of the country city table associated with the second level of the country transaction, will be needed. However, since the description of the reality we're analyzing does not include the city concept, we will model the country as a simple transaction. Let's move on to member. For this, we define the member transaction with the following attributes. Member document, which corresponds to the ID card, and therefore is not auto-numbered, so we define it as an 8-digit numeric value. Member name, of name type. Member image, of image type. Member address, based on the address semantic domain, and member phone, of phone type. But in addition, reality tells us that members must be over 20 years of age, so we need their date of birth and age, which should be calculated automatically. So, to the transaction structure, we add these attributes: member birth date, of date type, and member age, a numeric value of 3 digits. How do we calculate the member's age? With the age function, which calculates the age from the date of birth and the current date. So we define member age as a calculated attribute that obtains its value from the following expression. Why do we use the today function instead of the today variable? Because it's not possible to use variables in the formula declaration. To check that every member is older than 20, it's enough to declare the following error rule. It should be noted that we're not considering in this analysis the declaration of rules for controlling basic data entry, such as, for example, controlling that a member is not entered without a name, and so on. Now let's consider the authors. We need to create the author transaction with the following attributes: author ID, author name, and author image. Also, we know that the country of the author must be registered, since every author has a country of birth. Therefore, we add country ID and country name, where country ID is a foreign key, and country name is an attribute that's inferred from that foreign key. In this way, we represent a one-to-n relationship between country and author. Now let's think of the concept of book. It's a strong entity that's also identified with an auto-numbered value, a title, a date of publication, an author, and the number of copies purchased by the library. But in addition, reality tells us that a book belongs to a literary genre, since it could be a novel, an essay, and so on. So how do we model the concept of literary genre? If we think that these genres are finite, a first option we can consider is the creation of an enumerated domain. But the categorization of literary genres has been changing over time, and is likely to continue to do so. So the enumerated domain doesn't seem to be the best option, as changes would have to be made manually, and it would not be scalable. We can consider a literary genre transaction with these attributes: literary genre ID and literary genre name. It's a good decision to define a unique index on the name of the genre, in order to avoid the registration of literary genres with the same name. But the book also requires registering the author and the publishing house responsible for its publication. The author is already defined as an entity, but the publishing house is not. And although it's not explicitly declared, in the analysis, the need to model the publishing house entity arises. So, we define the publishing house transaction with these attributes: publishing house ID and publishing house name. We can also create the corresponding unique index on the name of the publisher. The library also offers magazines and notebooks to its members, so we define the magazine transaction with these attributes: magazine ID, magazine title, magazine image, magazine publication date, and magazine copies to record the number of copies purchased. In addition, there's the notebook transaction with these attributes: notebook ID, notebook image, notebook description, and notebook status. A notebook is available or checked out, so we define the status enumerated domain with these values. Now let's analyze the concept of loan, which is essential in this reality. The library allows a member to borrow a notebook, 3 books, and 4 magazines for 15 days. We then have a one-to-N relationship between the entities loan and notebook, and an end-to-N relationship between loan and book, and between loan and magazine. How can we model it? Let's analyze a first option. We create the loan transaction and define the following attributes: loan ID, loan date, member document, member name, member address, loan return date. The return date is requested to be calculated automatically. A loan is made for 15 days, so we declare the following calculation associated with the attribute loan return date. In addition, a loan may or may not include a notebook, so we add notebook ID and notebook description. But in this loan transaction, notebook ID is a non-mandatory foreign key. Therefore, we set its nullable property to yes. A loan includes several books, with a maximum of 3. So we define a second level to record them, including a loan book comment attribute to record any comments needed at the time of the loan. How do we control that no more than 3 books are entered? We can define a new loan books quantity attribute that counts that amount and then condition that value in an error rule. But the same loan can include up to 4 magazines, so we can define another second level parallel to the book to register the magazines. It's also possible to control that no more than 4 are checked out. The reality clearly describes that the registration date of a loan must always be the current date, with no possibility of being modified. To this end, we declare the following rules. Although the objective of this video is to focus on analyzing the transaction design, we're going to suggest an implementation option so that, when registering a loan, only notebooks that have available status are offered. This implementation can be done from the definition of the transaction itself, and that's why we include it. We're going to remove the notebook description attribute, because we'll disguise the identifier of a notebook with its description. We select Notebook ID and define it as a dynamic combo box, with Notebook ID in the property Item Values, and Notebook Description in the property Item Descriptions. This will load all the notebooks registered, so that only those with available status are offered. We declare the following condition. Although this is not the only way to control that a notebook is available when registering a loan, it's an implementation that can be solved from the definition of the transaction itself. Also, we must configure the empty item property to true, since Notebook ID may not be chosen because it can be null. Another necessary requirement is to know the availability of books or magazines in high demand. We know the number of copies purchased by the library for each book and magazine, but we don't know how many are still available, Can we obtain these values in a simple way and based on the transaction design? If in the book transaction we define a new attribute, book on loan quantity, we can calculate the number of copies borrowed and therefore know the number of copies available. What happens if we associate the count loan book comment calculation with this new book on loan quantity attribute? Will it effectively sum the number of copies of that book that have been checked out? The answer is yes, because the table associated with the transaction where we define the calculation is book, and the table where the calculation is resolved is loan book, since it's determined by the loan book comment attribute. Between both tables, there's an attribute in common, which is book ID, and therefore, it's an implicit filter that Genexus will apply. That is to say, this calculation will return the total number of copies of that book that have been loaned. But we need to know the number of copies currently checked out, so we have to add a condition to the calculation that allows counting the number of copies currently checked out. For this purpose, we consider loans whose return date is greater than or equal to the current date. We can state the following. The server_now function allows obtaining the server's current date and time. The today function could also be used. Can we declare this calculation condition? Yes, because the attribute involved, loan return date, belongs to the extended table of the table where the declared calculation is resolved, which is loan book. Therefore, if we know the total number of copies and the number of copies currently checked out, then we can know the number of copies currently available. So the structure of the book transaction looks as follows. In the same way, we can know the number of available copies of a given magazine. Now we have all the information we need to validate a loan. So let's add the necessary attributes to validate the availability of the copies to be borrowed. Book available quantity at the book level, and magazine available quantity at the magazine level. And we control with the following error rules. So far, we've met the requirements to register loans. But let's look at the form generated for the design we've made. What associated tables are created by Genexus for this loan transaction? It creates 3 tables. Loan, associated with the first level, with loan ID as primary key. Loan book, associated with the book level, with loan ID and book ID as compound primary key. And loan magazine, associated with the magazine level, with loan ID and magazine ID as compound primary key. By defining 2 parallel levels, we see parallel grids in the form. This may be cumbersome for the end user, who may request to simplify the design and manage the information in different, simpler screens. For the current design, Genexus has created the following tables. We should remember that we must always analyze, evaluate the reality to be modeled, and implement the option we consider correct. And for this, it's essential to always work together with the end user who will guide us in selecting the design. Let's not forget that the application must be a support tool for end users to better manage and develop their business.